Okay, we just went through this question on how to get the average values using statcrunch. Also, how to make bins and make a bar chart using those bins that is stacked. So again, the summary, we just went through the summary, the stats menu. For the graph, you just go to the graph menu. The next question with statcrunch is the one that we looked at before with the confounding data example. So I'm going to click that to open it in statcrunch in the background. Again, I've got my issues with my automatic scrolling that I'm going to try to avoid being a problem. Okay, so in this case, I'll just explain it to you in the data, I guess. I've got four columns for each study, and there's a separator between the two studies in the middle here, that X column. But otherwise, I've got four variables represent my treatment for each subject. There's a variable I control. This could be like gender, so maybe it's male, female, and I've controlled it so I only have people of type A. The second variable is the one I vary in the treatment. So that's, I give one group of people placebo, I give one group of people the drug. There's a third variable that I don't control. It's just sort of, I would say it's random, but that's not technically true. I just have not controlled it. Some people could be, so let's say I did my trial, my study, and I was giving out drugs and placebos, call people in. I just put them in two groups without paying any attention to this other variable. I don't know how many of each type of person, X, Y, or Z, went into the placebo group or the drug group. So that wasn't controlled. But then I have my response variable. So after I give the drug or the placebo, I see how they score on some disease test. And people with lower scores have less disease. The higher score means more disease. But that's all here in the fourth column for the response variable. We're testing to see if it's affected by the varied variable. And what this example should show you is that there's confounding could be an issue. If there's another variable that also affects the response in addition to the one you're varying, you have to either control it or randomize it. And so we should see that we'll get different results between these two studies. In the one case where we did not control it. In the second case, we do the exact same thing, but with a different set of data. We have our, let me expand these out. You'll see a version 2. So variable 1 controlled. And the second study, variable 1, it's the same study, but they control this one now. Sorry for the scrolling. And this one, it's called version 2 to show that it's part of trial 2. But anyway, they run a second trial, same exact setup. They control the one variable, all females, let's say. They break them into two groups. Half will get placebo, half will get drug. This time they did check the third variable, and they made sure that they had this, same number of X's, Y's, and Z's in both the placebo group and the drug group. And then they check their scores. And we'll see how that changed the results. So let's start by going through this. Back to our question really quick. That explains the data. You've got the four columns. There's a fifth separator, then the results from the second study on the next four columns with the version 2 after each of those. Also, you'll notice that variable 3 says not controlled in one case, and then in the other it says randomized. After that, you have the questions. It'll sort of guide you, this question. It's very long. This is going to be time consuming, but I don't think it'll be difficult, especially with this video. But make sure you want to make some time to do this homework. Okay, so it says let's start with the first study, the first four columns on the left. Analyze the average value of the response variable. So I just want a numerical summary, the average of that response variable column, the fourth column. Here's the title of the column. I want to analyze that column, the fourth, grouping by the second column, the varied variable, drug or placebo. So what was the drug response based on drug or placebo? To do that, I have this in brackets. You go to the stats menu, summary stats columns, and then you will enter what you get here for the placebo group, for the drug group. So let's do that. Here's my data, stats, summary stats, columns. What column do I want to summarize? I want to do it for the variable 4, the response variable, in the first study before we randomize. I'm going to group by whether or not they got drugs or not. And then I'll hit compute. Here is a huge graph. Sorry for the menu thing, for the scrolling issue. I've got my drug group on top and my placebo group on bottom. I can see my average values here. So I can see the drug group has a lower score on average than the people who received a placebo. So it seems like the drug is working in this study. If I'm rounding to a tenth, this will be 0.9, that'll be 1.2. So I'm going to put those in. Oops. Okay, so in the first study, what is the average value of the response variable for the subject who received the placebo? That was 1.2, it was slightly higher. This was 0.9 for the people who received the drug. Okay, so now analyze the average value of the response variable, just like we did before, but this time grouping by the thing we did not control. So I have to go to stats, summary columns, just like I did before, only I'm going to choose a different grouping. And then I'm going to enter in what the X types had for their score, what the Y types had for theirs. So I'm going to do that now. There's a couple ways I could do that. I'm going to leave this menu up. I could go to options and edit, and I could change this menu to be what I wanted just by changing how I'm grouping. I'm going to make a whole new menu though. Let me shrink this so you can see more. Stats, summary stats, columns, same response variable, this time grouping by what I didn't control. Let's see those numbers. For X, Y, and Z, I have the different groups have different outcomes. So those groups were not the same. Looks like Z people are healthier than the other two. So that itself could be the reason why some people did better than others. Maybe it has nothing to do with the drug. Maybe this is a lurking variable. And actually it is. We'll see that it is. So I just got to enter in these 0.9, 1.5, and 0.7 for my scores for the different types. So in the first study, what's the average value of the response variable for subjects of type X? It was 0.9, 1.5, and 0.7, I believe. Then, yeah. Now I have to create a bar chart for the second variable. So I'm not looking at the drug response or the disease response. I'm looking at their whether or not that they received the drug or not. Sorry, I paused it. So I'm not varying it by the disease response, but by whether or not they got the drug. And what I'm grouping by is X, Y, or Z. Let's make that graph and you'll see why I want that. Okay, so here's our data again. Let me expand that so it stops scrolling on me. Graph, bar chart with data. Now we said we want to look at, we're outputting drug or placebo this time, and I'm grouping by X, Y, or Z. So let's give that a try. Okay, so we get our nice graph. Shows you for the group that received the drug, you had 9 people who were of type X, 7 of type Y, 14 of Z. 9, 7, 14 got the drug. That's what they're asking. The first study, how many subjects received the drug who were of type X? 9. I'm already forgetting what we said. 14 and 7, was it? Let me see. Oh no, it was 7 and 14, I think. Let me just double check. 9, 7, 14. Good. Now, how many of each type received the placebo? 14, 12, 4. This time they had 14 X's, 12 Y's, and 4 Z's. So notice, remember we said the Z's had the lowest disease score of all the subgroups. And now when we look at the two groups, drug and placebo, the drug group had 14 healthy types, while the placebo group had only 4. So that alone we're going to see is what explained why the one group had a lower score than the other. It wasn't the drug, it was these types. Okay, so once we enter in that, we're pretty much done. We're going to repeat that whole process for trial 2, and we're going to get slightly different results, but you got a couple of questions here before we do. Based on these answers, were the placebo group and the drug group homogeneous in the first study? Are they the same type of group with the same features? Remember, the definition of homogeneous was that they should have the same statistics, or have the same chance to. Were they homogeneous in this group? No, because they did not have, look, they had different types of subgroups. They were not homogeneous groups. That picture, this is not flat, so it's not homogeneous. These are not the same. I guess they didn't have to be flat, but if they looked identical, they would be homogeneous. These are not. Based on the answers, were they homogeneous? No. Based on these answers, does the drug seem to be associated with lower levels of disease in the first study? I'll say yes to that one, just because, I mean, we're suspicious of it, but whoops. When we look at the data, drug, lower score, placebo, higher score. So yeah, it does look like it brought it down, but we're going to see this is what really explains that. Okay, now for this second part. Actually, I'm going to stop this video since we're at 13 minutes, and we'll make another video for the second part where we do the same thing for the second study.